Welcome to this visual guide on mastering React hooks. If you are a developer looking to build dynamic, efficient applications, understanding hooks is your superpower. Hooks are simply special functions that let you hook into React state and lifecycle features from functional components. They make your code cleaner, highly reusable, and remove the need for old-school class components. Today, we are going through the most essential React hooks every developer should know. Completely beginner-friendly, packed with real use cases, and easy to understand. Let's dive in.
Let's start with the absolute foundation of interactive React apps, use state. The core concept, use state lets you add state to functional components. It returns exactly two things, a current state value and a function to update it. Take a look at this simple counterexample. How it works behind the scenes. Initial render. We set our initial state to 0 inside useState0. The UI displays count 0. The trigger. When a user clicks the increment button, the setCount function is triggered with the new value, count plus 1. The magic. Crucial note. When state updates, the component automatically re-renders with the new value. The UI seamlessly transitions from 0 to 1, then 2, then 3. Real-world use cases. You will use useState constantly for counters and gaining scores, form inputs and validation states, toggles like showing or hiding a sidebar/UI state, managing shopping cart items and selections. Pro tip: state should represent changing data. Keep it minimal and meaningful. Don't overcomplicate your state if you don't need to.
Next up is useRef. Beginners often confuse this with useState, but they have completely opposite behaviors. The core concept? useRef returns a mutable ref object whose .current property persists between re-renders. The big secret? Changing .current does not trigger a re-render. Let's see it in action with a focus input example. How it works. When the component renders, input_ref holds a reference block pointing to current input. When you click the button, handle focus reaches directly into the DOM using inputref.current.focus to highlight the box. The value persists perfectly behind the scenes without forcing the screen to redraw. Real-world use cases. Accessing DOM elements directly, like focusing inputs, playing video media, or measuring element sizes. Storing timers and interval IDs, keeping track of previous state values, managing mutable values that don't directly change what's printed on the UI. Pro tip: use ref for values that don't impact rendering. It's perfect for sneaky performance optimizations.
As your app grows, you'll find yourself passing data down through dozens of component layers. This headache is called prop drilling. Use context is your escape route. The core concept. Use context lets you access shared data across the entire component tree globally, completely bypassing the need to pass props manually through intermediate levels. Here is how you set it up in 3 clean steps. How it works. Without context, an app passing data from app, layout, page, button forces layout and page to handle props they don't even care about. With use context, you plug a provider at the top and the button directly pulls the data from it. All child components can access the exact same context value with ease. Real-world use cases. Global themes. Light/dark mode switches. User authentication state, storing the current logged-in user's info. Language localization. English, Spanish, etc. Global app settings and preferences. Pro tip: use context for global app-wide data, not for local component states that only matter to 1 or 2 files.
Performance mattering as much as it does? Let's talk about optimization. Say hello to useMemo. The core concept, useMemo memoizes, caches, the result of an expensive calculation. It ensures that a heavy function is only rerun when its specific dependencies actually change. Imagine calculating a massive factorial number on every single click. How it works. Before useMemo, every unrelated UI change or re-render triggers the calculation loop again. Render 1, calculate. Render 2, calculate. Render 3, calculate. This wastes immense CPU power. After use memo, if the component re-renders but the number dependency stays exactly the same, React skips the calculation and instantly serves the cached result from memory. It recalculates only when number moves. Real-world use cases: heavy mathematical or data sorting calculations, filtering or sorting massive arrays and lists before rendering, transforming complex API data structures. Pro tip: don't use memo for cheap, fast calculations. Memory allocation has its own overhead. Use it strictly when the computation is genuinely expensive.
Similar to use memo, we have use callback. While use memo caches a calculated value, use callback caches a function reference. The core concept: use callback returns a memoized version of a function that only changes if its dependencies change. This keeps function references stable between renders. Take a look at this setup with an optimized child component. How it works. In JavaScript, functions are objects. Every time a parent component re-renders, it recreates a brand new function reference. If you pass that function to a child component, the child thinks it received brand new data and re-renders unnecessarily. Without use callback, parent clicks cause child to re-render every single time. With use callback, the function reference remains identical across renders. The child skips rendering entirely, boosting performance. Real-world use cases: passing callbacks to optimized child components using React.memo, preventing unnecessary effect triggers in large lists, improving responsiveness in heavy interactive rendering windows, creating stable function references for event listeners or subscriptions. Pro tip: use callbacks specifically when passing functions to memoized child components or inside dependency arrays. Don't sprinkle it everywhere blindly. When your state transitions become complex, use state can quickly turn messy. That's when you call in use reducer. The core concept: use reducer is an elegant alternative to use state, built specifically for managing complex state logic. It makes state updates predictable by separating actions, what happened, from the reducer, how the state changes. Look at how beautifully it structures a multi-option counter. How it works: instead of updating values directly, you lay out a dispatch workflow. Dispatch an action. The UI sends a statement like type equals increment. The reducer decides. The central reducer function evaluates the action type and calculates the brand new state cleanly. UI updates. The centralized, isolated logic updates predictably, making debugging and testing a breeze. Real-world use cases: e-commerce shopping carts, adding, removing, altering item counts, multi-step wizard forms with shared validation, undo and redo application features, global game state management, complex UI component state transitions. Pro tip: upgrade to use reducer the moment your state logic relies on multiple subvalues or when the next state depends heavily on what the previous state was doing.
Most of the time, you will use standard asynchronous use effect to fetch data, but occasionally you will encounter layout glitches. Enter use layout effect. The core concept: use layout effect is almost identical to use effect, but it runs synchronously immediately after all DOM mutations and before the browser paints the screen. Here is an example measuring a dynamic tooltip box layout. How it works. Let's look at the operational timeline pipeline. Render phase. React calculates updates to the DOM. Use layout effect fires. Runs synchronously here. You can safely measure or mutate dimensions. Browser paints. The browser displays the finished, properly positioned layout. Use effect fires. Runs asynchronously after the user already sees the screen. If you try to position elements using use effect, the browser paints the wrong position first, then jumps to the correct one, causing an ugly visual flicker. Use layout effect blocks the paint window until updates complete, ensuring smooth, flawless UI updates. Real-world use cases. Measuring real DOM element sizes, width, height, page positions. Explicit positioning for tooltips, modals, and popovers.
adjusting complex element layouts right before a user sees them, completely avoiding visual glitches on heavily dynamic layout recalculations. Pro tip: use layout effect sparingly. Because it blocks the browser from painting layout updates, overusing it will noticeably drag down your app's performance.
The golden rules of hooks. Now that you know the hooks, you must follow the laws that govern them. Breaking these rules will lead to unpredictable behavior and messy application bugs. Rule 1. Only call hooks at the top level. Never call hooks inside nested loops, logic conditions, or inner functions. React relies on the exact order in which hooks are declared to track state correctly between renders. Keep them right at the top of your component definition. Rule 2. Only call hooks inside React functions. You can only call hooks from within React functional components or inside custom hooks you build yourself. Do not attempt to use them in standard vanilla JavaScript functions. Rule 3. Do not call hooks inside loops. Putting a hook inside an iterative loop, like a .map statement, breaks React's render order indexing completely incorrectly. If you need item-specific tracking states, move that code out into its own dedicated child component.
Common mistakes and how to fix them. Even seasoned React veterans make mistakes. Let's look at the top 4 traps and how to dodge them cleanly. Mistake 1. Missing dependencies in useEffect. If you write a hook tracking a value, like a changing variable counter, but leave the dependency array completely empty, bracket bracket, your effect will miss changes entirely. The fix: explicitly include all state or prop values used inside the effect within the dependency array, bracket count. Mistake 2. Calling hooks conditionally. Wrapping hooks inside an if block breaks rule number 1 and collapses React's execution tree order. The fix: call your hook unconditionally at the top level first, then build your standard conditional logic blocks inside your hooks or standard variables down below. Mistake 3. Calling hooks in loops. Using a hook inside a list mapper breaks state order. The fix: isolate the individual list layout. Move the interior JSX loop contents into an independent child component, and call the hook safely inside that child. Mistake 4. Not cleaning up effects. Setting up open intervals, set interval, or stream subscriptions inside an effect without cleanup will cause massive hidden memory leaks. The fix: always return a clean cleanup function, like return clear interval ID inside your effect to shut down tasks safely when a component unmounts. Summary checklist for stable code. Trace and debug unexpected behaviors methodically. Correctly profile re-render performance bottlenecks. Prevent memory leaks and application crashes by cleaning up side effects. Pro tip: when in doubt, read your linter error messages carefully and run eslint-plugin-react-hooks. React will thank you.
Now that you have built-in hooks down, it's time to unlock the ultimate level of React architectural design: custom hooks. The core concept: custom hooks allow you to extract complex stateful logic out of your UI components and package it into a clean, reusable, testable function. The absolute requirement: custom hooks must start with the word use, e.g. use counter, use local storage, which unlocks React's ability to cross-check them against the rule of hooks. Let's look at a custom use counter example. How it works behind the scenes. The most vital concept to remember is that custom hooks share stateful logic, not actual state instances. If you use counter inside 3 separate components on the same page, each component gets its own completely isolated, completely independent block of state. Let's look at another incredibly popular pattern: syncing state to browser storage using a custom use local storage hook. This abstracts away the side effects entirely. Your visual components don't need to know how local storage works. They just read values cleanly. Major benefits of custom hooks: reusability. Write your data manipulation layer once and share it across dozens of front-end screens. Readability. Keeps your visual components extremely clean and tightly focused purely on layout presentation. Testability. You can easily isolate and run functional unit tests directly on your business logic without rendering heavy UI structures.
Maintainability. If your data API or local sync requirements change, you only have to fix it in one single centralized file. Pro tip: name your custom hooks descriptively, keep them tightly focused on a single responsibility, and compose them together to build clean, modular front-end systems.
Conclusion and summary. We have reached the end of our deep dive. Let's wrap things up with a quick, high-level summary of everything we've learned to lock this knowledge into place. Use state hook adds reactive state to functional code blocks. Use case: shopping carts, form inputs, counter values. Use reducer hook manages complex state via structured actions. Use case: multi-step forms, undo-redo mechanisms. Use effect hook performs asynchronous operational side effects. Use case: API data fetching, event listeners, intervals. Use layout effect hook synchronously handles logic adjustments before paint. Use case: dynamic layout positioning, tooltip fixes. Custom hooks extracts, packages, and reuses modular logic. Use case: authentication state, local storage syncing. Key takeaways to carry with you. Hooks give you full access to React's engine features directly inside simple, readable functional components. They promote outstanding reusability, readability, and long-term maintainability. Always respect the golden rules of hooks to ensure your code runs cleanly, predictably, and remains bug-free. Custom hooks empower you to build your own clean abstractions, helping you write cleaner code. Your continued hooks journey. Mastering hooks doesn't happen overnight. It's a path built in stages. Step 1. Learn. Understand the absolute basics and internal operational mechanics. Step 2. Practice. Implement them step by step in small, self-contained mini projects. Step 3. Experiment. Push yourself to compose sophisticated custom hooks and advanced design patterns. Step 4. Build. Deploy robust front-end web applications. Step 5. Master. Confidently write clean, scalable, production-ready React applications. Keep coding, keep exploring, and most importantly, keep creating amazing things. See you in the next tutorial.